I think we should start for the first presentation. Are you ready?
Yeah.
Okay.
Okay. Can we start?
Okay. Yeah. Okay. So we shall start the first presentation by Dr. Rafidah Petra. The title is Developments of Nano-Sensor for Halal Authentication in Food. Dr. Please go ahead.
Thank you very much, Professor Somnuk, for the kind introduction. Sawadika, and good morning, ladies and gentlemen. We hope everyone is well and morning coffee has kicked in. First, we'd like to say thank you to the organizer, ASEAN IVO and ICT and Chulalongkorn University for giving us the opportunity for us to be in this forum. It is a great pleasure to be in this beautiful country, Thailand. I'm Rafidah, representing our team to share on our proposal on the development of nano-sensor for halal authentication in food. Allow me to share my experience when I was abroad. About 18 years ago, I was in Glasgow for my bachelor degree. And my friends and I went out for some dim sum buffet. Little did I know that the dumplings that I had pork filling in it. About 5 years ago, I was in Berlin for some silicon photonics conference. And in the evening, I went around to get a vegetarian burger from the nearby McDonald's. And I had a bite and to find out that I was chewing on a meat patty instead of the current vegetarian burger that I ordered. So now let us bring you to our proposal in bridging the gap between nanoelectronics and nanophotonics and halal science. So halal foods can be defined as food that be consumed by Muslims that are allowed to be eaten and drink under the Islamic or Sharia law. That would be in the context of its contents and its preparation. We acknowledge that Islam constitutes the world's second largest religious group, amounting to 1.97 billion adherents across the world. And there has been an increased consent in obtaining halal food and beverages products, both in Muslim majority and minority parts of an area. And in food industry, there has been an alarming concern in food adulteration. We take meatball manufacturing as an example. Pork is mixed with either chicken or beef in the meatball manufacturing in an effort to lower down the production price and at the same time to improvise the taste in a cheap way. So in this presentation, we'd like to propose the use of nanotechnology, specifically nanoelectronics and photonics, to address the mentioned issue. And our objective is to devise a handheld portable nano sensor for halal identification of the presence of specific animal DNA in food products. Let us look at nanotechnology at a glance.
Recording stopped.
Uses the structure between 1 nanometer and 100 nanometer in size to create materials, devices, and systems with new and useful properties and functions. And look at the classic.
Recording in progress.
Carbon nanotube is 10,000 times smaller than human hair. The pictures in the next slide shows various nanostructures based on carbon and silicon materials. And these materials, these nanostructures are made possible through the fabrication and characterization in a controlled and regulated condition clean room. And we acknowledge that nanotechnology has given positive impact to our everyday life in terms of high data connectivity, smart electronics equipment, solar panels, renewable energy, medical applications, and in food industry. Focusing our attention on food industry, the application of nanotechnology in food industry has been around for quite some time, targeting the following areas as for ingredients, packaging, storage, dietary products, and nanosensors to detect contamination, among others. So these pictures here shows that nanotechnology has well progresses in terms of the industry. We have all this commercialized as well. And going through the next slide, with escalated concern in halal food and obtaining halal food, this is adulteration in food production, give a motivation for us to propose the halal nano-sensor. And a number of works have been reported on the detection of meat contents using gold nanoparticle solution through colorimetric sensors. And they reported that nanoparticle solution containing chicken DNA will turn pinkish color, and those which contain pork will turn grayish color. So we are proposing to design a fabricate sensor to detect the presence of specific animal DNA. The structure is adopted from a reported gas sensor, and in this case, utilizing nanostructured material. We propose to use zinc oxide nanoflowers. And the idea again is to design a portable handheld halal application sensor similar to the food ingredients detector, the one that I've shown in the previous slide. And further, it is proposed to integrate the portable halal device with an IoT application to be implemented in food factory for remote monitoring. And the next two slides is showing some typical activities in the clean room fabrication in order for us to obtain those nano-sized dimension devices. As a conclusion, the objective of this project is to bridge the gap between electrophotonics and halal science to design and fabricate a sensor to detect the presence of specific animal DNA. The structure is adapted from a reported gas sensor, in this case utilizing nanostructured material as a sensory component. And we propose to design a handheld portable product for halal application similar to other commercialized food ingredients detector. And once it is developed, we propose to integrate the portable halal authenticator sensor with an IoT application to be implemented in food factory for remote monitoring. And this proposed project revolves around the 17 elements of the SDGs to provide integrated solutions that challenges the global communities currently facing in terms of food security, reduce inequalities, responsible consumption and production, as well as while ensuring inclusiveness and strong partnership among the global society. That's the end of my presentation, Professor Somnuk. Thank you.
Okay, so now I invite a question from the floor. 10. Yes, please.
Just because you check the system to check the meat of the animals, right? How can you make sure? I asked you. How can you make sure that it is halal food? You see, because halal is not only it not only depend on the DNA of the animal.
Yes,
it's various. I mean, I'm not an ulama. I'm not a specialist on this, but it is not only in the type of animal DNA. Thank you.
Thank you very much for the question. Yes, we understand that halal include everything in terms of the contents of the product, food product, as well as in terms of its preparation. In our proposal, we are not going beyond the in the context beyond of the contents of the meat or the DNA. At this stage, we are only proposing in terms of the detection of different DNA from chicken, beef, or pork. But yeah, I'm not coming from a halal science background, but that is something that we need to bring in as well when we need to consider. Thank you very much.
Okay. Okay. Thank you.
Yes, sir. Fabrication. Yeah. So we are. Thank you very much, Prof, for your question. We are teaming up with University Sains Malaysia. So we have a partner there to fabricate the device in USM using the clean room. Yes. No, University Science Malaysia.
Okay, now.
Yes,
So we just wait until she finishes.
they have. Yes,
Thank you.
yes. No, no, yes. Yeah, we are open for any collaborators to fine tune the product on another stage of the manufacturing of the sensor. Thank you very much, Prof.
Okay, if there are no other questions, may I invite the second presenter?
Thank you.
Second presentation is by Dr. Somnuk. The title is The IoT Application in Clean Agriculture.
Thank you, whatever. I didn't count it in.
Okay.
So when they do the presentation.
I think we should have it.
4, 3, 0.
Yeah.
Yeah, thank you very much.
Yes.
Yeah, thank you very much, Professor Somnuk, and good morning, everyone in this meeting hall. It's my great pleasure to be represented by my university, National University of Laos, to join this meeting. Actually, I've been participate with this program for a while, and so it's very happy and very glad to meet all of you again here. So today, I would like to introduce one of my laboratories research works that we try to introduce one of the IoT application to the area of the agriculture. The background, as we know that Laos is one of the country that we are very consider about the naturals. And we try to promote the thing is the one we call the CAs, clean agriculture, because of the originally we are the people that are farmers that use a very natural way to plant the agriculture products. This is one of the projects that are supported by JICA that are trying to promote the clean agriculture to the Lao society. But once we try to promote, stop using some chemicals, stop some using the chemical fertilizers, the problem is turn out that the quality of the crop is not very good. So the taste not good. When as we plant something that we need the fruit very sweet, but not really sweet, and that they turn something out very low quality. So that's why we come up with this kind of center to check what is the problem that we're going to solve. So thing that I mentioned here. So we have insufficient technology to support a CA producer. The second thing, we are unable to produce the large amount of the crops according to the market needs and many problems that we facing now. So very difficult to control the production costs also, and potential to produce costs regardless of the season. So so if we use chemicals, stop everything, so we just wait for a season. If the rain is good, environment is good, so the crop is good. So it's not the industry one. So these are the target of these projects that we try to promote the IoT technology to the clean agriculture product. So this is quite broad, but I'll try to focus more. So I try to focus some of the parameters we can control, we can study what is the parameter that improve the quality of the product. So I say the NPK, so it's a nitrogen, phosphorus, and potassium. This is a 3 key measure that a parameter that we are focused on. As you see the photos here, we can say that the structure of the soil nutrition of fertilizer, of course, the plant needs many ingredients like oxygen, let's say CO2, water, and some mineral is in the ground. So many research already done with, okay, I try to control the temperature, humidities, and so on. But there are some fields, researchers try to understand what is under the ground, what is the components in the ground that need for the plants. So I come up with the three parameters here, N and P and K, so nitrogen, phosphorus, and potassium. So the thing is, once the crops, and in this research, we focus on only the tomatoes. Tomato first. Tomatoes is one of the agriculture product that is good for the market, and we cannot produce all years, but try to use this crop as our laboratory. So we have found that many issues that this is from the internet pictures. So once we not enough nitrogen, not enough potassium, phosphorus, and also potassium, there will be turn out some problem with the healthy of the plants. So we come up with this sensor. Actually, we try with many sensors that are available in the market right now. So we try to figure out how to detect this kind of the structure or components of the chemicals under the ground. So we call the nutrition of the soil. So we use this sensor. This we call models PR300 PQA number N01. This is sensor. These are three probes here. Basically, it's use electromagnetic sensor, so electrical sensor, to detect the components in the soil. And we experienced in the one of the greenhouse one. With we took 18 samples. So this is a line that we try to plant this tomato plants along this line. So we will take sample about 18 holes, 18 samples in the greenhouse one. Then we try to collect the data. Then of course, once we collect data, and also we also use other type of sensor like humidity, temperatures, and also the fans and others wireless sensor to transmit this kind of data to the clouds. This is the real experiment house that in the farm. This is one of the farmers that are interested in this works, and they asked our team to come and to do some experiment in their farm. Currently, is that we check with this is the point, the sample point, the 18 points. Sorry, this is 17, but totally is 18 point that we collected data. We saw that so this is the main nutrition facts in the ground, so N, P, and K. So in each area, they show the different kind of data. So once we plant on the ground, so I mean we got a very different nutrients in each plant. So we very difficult to control. So I mean that one plant, so that if they have meet the requirement, the conditions, it's very beautiful and very sweet and tastes very good. And some point not good. So that's why we try to, maybe we cannot plant in the real grounds here. Maybe we plant in the plastic. No, sorry, in the bags, and we can control everything in the bags. And so before we try to test this, we also try to evaluate different kind of sensors. Also, we buy many kind of sensors, but the result that turned out very different. So different sensor give different result. So we try to different sensor and try different kind of the soils also. So we try to learn everything about the soils currently. So this is on the plant, we see kind of a different result here. Let me focus on the tomato products that we are interested in. the tomato product, maybe they might need about 300 milligram per kilos of earth, of earth. 1 kilo of earth will be contain about 30 milligrams of nitrogens and about 3 to 8 grams of phosphorus and 25 to 50 of the potassium. So it should be, this is should be the ideal case of the tomato to make the good tomatoes, sweet tomatoes, high quality of tomatoes. Once we take the plot the graphs of this kind of NPKs of the soils between the 18 sample here, we found that the dashed line here said that this standard from this graph, the standard here, but this is the actual that we have. So we will see that the nitrogen is very high. So it's because of what? Because of the farmer, maybe they give a lot of ureas in this area. So that's the makes too much nitrogen here. So let's say it's very difficult to control the cost because we don't know what happens in the grounds there. So when we see the plants are not healthy, we try to give them some fertilization, but without any information to check that. So if we have this kind of information in your hand, maybe the farmer will deal with the right way. So maybe you will know that, okay, nitrogen is too much in this time, so we will stop. We will use another potassium or phosphorus or others also. Once we know from the experience of the farmers, say that different age of the tomato, they need very different components of NPK. So once the tomatoes are very young, maybe they need a lot of nitrogen for increase the growth of the tomato plants. Once the tomatoes turn to be the fruit, to give the fruit of tomato fruit, we need more in the potassium to make them sweet. So we have to collect all data, all the age of this tomato fruit. So that's why this is a quite challenge for us to continue to work on this project. The projects, we come to the conclusion that we is the very beginning phase of the project. This is one of the project that my student they took from some of the farmer, the real case of farmer come to the laboratories, and then we try to learn the setup, everything. So this is a very basic. Currently, we still in the state of evaluation the sensors, and we try to collect the data, try to learn the data first. But we need to, but we still need to confirm the result with the traditional chemical laboratory. So whether the result that we examine from our sensor with the traditional case one, how it's different. So we can confirm. After confirm that, we will continue to collect data and we will do some data analytics, and we might have some dashboard and have some very user-friendly, very easy to understand for the farmer. This is our next phase. So thank you very much for my presentation for today.
Thank you, Dr. Somnuk. May I invite a question from the floor? Please, microphone.
Thank you very much, Professor. Your work is very interesting. Since I am from agriculture family, that's why I'm excited to give a small suggestion. Saying that NPK is the major nutrients, there is a micronutrients also, like gypsum and other things.
Yeah.
Naturally, when you are growing a plant, you are giving, at the time of growth, you are giving more urea. Urea is containing ammonia, that is nitrogen.
Yes.
And the PK, phosphorus and potash, potash and phosphorus is giving the fruit.
Yeah.
So when your farmers, what they are doing is they are giving more urea to see the plants are growing well. But
Right.
it will take more water and grow well. But at the same time, if you have the more water in the plant, which will give the fruit is not so concentrated.
Yes.
Here, mainly you are mentioning about the sweetness of the tomato, because of if you are not getting proper sunlight also, the more water will be in the tomato, so that the taste will change. So you have to not only concentrate on only NPK, there is a micronutrient plus the sunlight. Sunlight will mainly affect, because since I have some experience on this, sunlight will cause major change the taste. Just for your information.
Thank you very much for your suggestion. This is very good. The information that I will request my team to looking more factor that that made the quality of the product. So sunlight is one of that. So thank you very much, Professor. I will look for that.
The crops initially they will give more water. At the fruiting stage, they will reduce the water, because that is the content. Because if you have more water, it will absorb more water and dilute the taste.
Okay, thank you. Thank you very much.
Okay, thank you very much for a good discussion. Thank you, Dr. Somnuk.
Yeah.
Oh, sorry, there one more question. Okay, we can have the last question.
I think we have seen many similar projects about the use of the IoT, you know, and then the solution for this. But I didn't see, you know, in your case, for example, you know, I think it's better if you already have the end user, and also might be the government agencies, you know, they're already involved, so that this project can be taken up. Right? As for the end users, you know, finally. Otherwise, many people have done it actually. Yeah. So we didn't know whether this how this one can be duplicated by others researchers as well, other country, for example, no. There's one now. Thank you.
Thank you very much for that good discussion. Thank you. May I invite Dr. Jocelyn for the third presentation. The title is Controlled Environment Agriculture for the Effective Growth of Plants in Indoor Farming.
Good morning, everyone. So in behalf of my teams from the Philippines, so I am Jocelyn Villaverde from Mapua University. So I would like also to thank ASEAN IVO for giving me this opportunity to present our project proposal. The title of our proposal is Controlled Environment Agriculture for the Effective Growth of Plants in Indoor Farming. So we all know that the effect of climate change takes a drastic impact in agriculture. So basically, some weather conditions as well as environmental parameters affect the growth of our plants as well as the crops. With the advancement of technology, the areas of the controlled environment agriculture, or what we call the CEA, so these concepts pertains to the circumstances where crops are shielded from the extreme environmental conditions and have the capacity to manage, oversee, or even regulate the microclimate of the cultivation area. So the CEA falls under the smart farming technology. So just like last Feb 2 of 2021, some farmers in the Philippines, specifically in Atok, Benguet, specific area in the Philippines, so they actually experienced the frost in their crops. So this frost occur normally during the amihan season, because the location of the area is somehow elevated. So because of this, normally the province of Benguet produces those crops. So they produce cabbage, legumes, strawberries. They provide also other vegetables, but during the cold season, the crops affect actually, or the harvest affect their yields. So because of this, so in order to address this issue, so we plan to replicate the normal environment conditions in the province of Benguet, where for now we will be dealing first with the strawberries. It will able to grow without frost-induced rays or somehow extreme weather conditions. And then specifically, we also want to construct a vertical indoor farm, which is capable of sustaining the controlled environment, which will be an effective alternative in growing as well as cultivating strawberries. And then part of the project also is it's low bat. So we part of the project also will monitor and simulate the no, it's low bat. It says low battery. Yeah, so it's okay. Okay, thank you. So part of the project will also monitor, simulate, and collect data regarding the growth of strawberries. And then this data will be gathered in determining the effectivity of the implementation of vertical farming. So for our proposed method, so the researchers propose to conduct the study of creating a controlled environment agriculture, which will be used to grow strawberries. And then this time we will be implementing the HVAC, or the heating, ventilation, air conditioning, and refrigeration technology, which basically plays a significant role for indoor farming. Somehow this technology sometimes are not implemented in vertical farming. So we want to implement the HVAC technology in our system. Based on figure 1, so this is how the setup will looks like. So we have the equipment for HVAC, such as the humidifiers, ductless aeration system, evaporating cooling, which will be which the equipments are very essential to control the climate inside the certain environment. And then this project will have 4 phases. So first part will be the conceptualization and research regarding the HVAC technology, as well as the equipments that we will be using in our system. And then followed by the optimization and fabrication. So where we will gather different parameters, what will be the effective parameters or conditions, whether to grow the effective or make the strawberry sweet, or it will become more yield, or it will give more yield. And then the equipments on the 3rd phase, we will undergo testing and simulations. And then for the 4th phase is continuity or the sustainability. So this is how we plan to set up our system. So we just base this one from the existing greenhouse environmental system. So as you can see here, we plan to implement it using a container van or inside the room, depending on the situation. In there, we will have different sensors that will be installed, where it will monitors different environmental parameters such as temperature, humidity, light intensity, water, as well as CO2. So these are the parameters that the plants really need in order for it to grow properly. And then we will use the HVAC equipments in order for it to control the environment inside the room. And then we are also planning to do application software for the monitoring of the different parameters in it. We plan to create a GUI as well as the web application for real-time monitoring of the conditions inside the room. Specifically, we will be able to, strawberries for the meantime. And then for the impact of this research, so using this technology and innovative controlled environment agriculture, this will give more people the ability to grow almost any fruit or vegetable in a small place, as well as some facilities might be constructed for community agriculture, which allows local residents to continue to grow the crops without incurring additional costs. And also with this kind of facilities, a huge advantage of CEA is that community members can grow food all year round. So we don't need to worry about the seasonal crops that will be available any time of the year. And then urban agriculture generally has been found to help decrease food shortage and provide access to a healthy food. So for the output or outcome of this project, so we are targeting to construct a vertical indoor farming And then also the proposed method will utilize HVAC equipment that will sustain the controlled environment to use in cultivating and growing of strawberries. In terms of agricultural sector, so this might be able to publicly available to the public, specifically targeting the agricultural sector as an alternative to the conventional form of farming. And for food security, so it will not eliminate, but somehow decrease the impact of weather climate-related constraints, such as the climate-related disasters. And of course, for the future researchers, this study will monitor, simulate, and collect data regarding the growth of strawberries, where they can be able to do basis on how what will be the effective temperature, the lighting conditions, and other parameters that might contribute to the growth of the crops. So for our conclusion, so the effect of climate change poses negative impacts on various sectors, as what I have mentioned a while ago, specifically for the agricultural sectors. So we are proposing the controlled environment agriculture in order for the crops to grow properly. That's all. Thank you for listening.
May I invite questions? Yes, please.
Hi, good presentations. I appreciate all the benefits you can gather with the urban farming technologies that you put in place. But have you did a calculation on the cost involved? Because challenge with urban farming, basically looking at the diagram you shared, you put in fans, aircon, sensors, you need to power up the whole setup. So what is your considerations on the cost, overall cost?
I know, basically for HVAC system, it's really expensive when we implement that one. But with regards to this one, this can be, this is doable with regards to the project of my team. So we can do a setup for the ventilation, the humidifier, and we can, but basically, yeah, it is really costly.
Sorry, just a follow-up. I think the real challenge is to how to make it more sustainable so that more people can actually benefit. Right, that's a real challenge.
Yeah, thank you. Basically, if we will be successful in this kind of setup, so we will be continuing to plant other crops rather than strawberries.
Okay, is there any other question? I have the same feeling that it is very costly thing.
Yes, actually.
And yes, and I'm not sure if it's worth it to probably it is something like we study the control in a certain level that can be, when we implement it, it can be used without all those expensive tools, such as maybe do the shading or do simple ventilation. Maybe, yeah, maybe that could work. We have more time left. Are there any more questions? Yes.
I think there's a reason why you select strawberries. There's a reason why you select strawberries as a specimen here for initial test. Is it because strawberries is actually an expensive fruits?
Yes, actually.
And therefore it helps justify the cost. Otherwise, I don't think it's worth it to actually do it.
Because normally if we bought strawberries in the market, it's really costly.
Okay, one more question then.
For overcoming that ventilation purpose, you are arranging some exhaust fans, all those things. Instead of that, you can create a natural venturi effect, so that you need not to install those things, so that you can minimize the cost. There are many methods to engineeringly you can reduce those things, and naturally you can. That is called venturi effect. Please apply that venturi effect. You can avoid those things.
Okay, thank you.
It's suggestion only.
Okay, thank you very much. I think that's it. Oh, thank you. Thank you. Okay, so we come to the last presentation for this session. Dr. Dang Tan Hai excuse me if I didn't pronounce your name correctly. The title is Research and Proposed Model of Wireless Sensor Network with Machine Learning to Monitor the Development of Medicinal Plant Artichoke.
Yeah, thank you. Thank you for your introduction. Good morning, everyone. Today I would like to talk about the wireless sensor network with the machine learning to monitor the development of the artichokes. Our group from Dalat University, Vietnam. This is the first is the introduction and research methods, research contents, and the last one is best resource and conclusion. So now I go on the introduction. I will know that the years information technologies is very popular now, especially in agriculture. This is a new trend. For example, wireless sensor network to collect the data, and we use cloud computing to store and process the big data, and also AI is very popular to training the data and to output the resource. In Dalat City, Vietnam, has some company or farm applied the information technology in agriculture, but only the basis. For example, automatic or risk integration system, but only they use on experiments, not use the machine learning to train in to collect the data. Also in Vietnam, in the last city, we had the famous plants, the artichoke. Artichoke is the medicine plants. It's very good and very healthy. And also in Dalat City, it has a suitable environment for growing the artichokes. Also, we have a great health benefits such as lowering the cholesterol, choosing lighter vessels. It can prevent cancer. This is our purpose of this research. The first one, we try to design a wireless sensor network to collect the data, and then we use the machine learning model to train in the data. And the last one, we try to test or evaluate the results from our model. And the next one, we try to introduce about the research methods. This is the proposal we had accept from Roman in Vietnam, and we will start next year from January 20 to the end of 2024. We will do this project 2 years in Dalat City, Vietnam. And the approach of the research is the first one, we try to discuss with farmers and experts who had experience or the knowledge about the artichoke. And then we try to explore some factors related to the role of the artichoke. And then we set up the wireless sensor networks to collect the data from land, air, and we propose the mathematics model and machine learning model to train in the data. I can summary about the research methods. The first one is data collection or processing. We will collect the data and we try to train in the big data by some tools like BSS or R language. And our research use the machine learning to try to train in the data. We use some methods of machine learning like clustering or classifications or some better in deep learning. Try to build up like the mass decision support system. And experiment methods, we try to compare our results to the real results from the reverse growth. It means the real result from farmer. And the last one, we try to attend some international grant like this, like today. to collect some new idea, some college. We try to modify or we try to the effects of our model. This is the research contents. The first one we try to research the overview in Vietnam and in other countries about the artichoke. And the contents two, did we try to design the wireless sensor network to collect the data, especially in Dalat City and a small town near Dalat City like you. It's very suitable environment for growing the artichoke. And also we try to publish some journal paper for this project. Also the next contents, we will the machine learning to train the data and to try to publish the new knowledge from all data. So we will try to build the application like the decision support system. Also, we try to publish some journal paper for this contents. And the last one, we build the application for the decision support system for the farmer. We try to build the math decision for growing the artichokes. This is our global models. We have at least two moisture errors. The first one in the lab and the second one maybe in Hajah in the one city near Dalat City. And we try to collect the data from the row of artichokes. And we will train in the data use AI control system. Yes, and to interact in control center. And we had the resource. And we try to build an application like decision support system for summer, for farmer. And the feature on the right top, it is the sample for the wireless sensor network to collect the data. This is our best resource for our proposal. Yeah, we must publish at least two paper, journal paper. And we also training some master student, at least one master student. And I summary about the application quotas. The first one is the wireless sensor network model for the collect data. And the second one is the environment condition controller for farming. And the next one is an environment data set in the big data for the full division of artichoke. And the next is the machine learning model, and the last one is the application decision support system for farmer to program the artichokes. This is the answer of our proposal, and I also remind about our research maybe needs about 10 to 15 wireless sensor to collect the data from the row of artichokes. It's maybe help us collect the data for training our machine learning model. Thank you for your listening.
May I ask question from the floor? Okay.
Yes, okay. Thank you very much, Mr. Dang, for the presentations. Actually, I have two questions related to this presentation. So the first, why do you need the artificial intelligence for this system? So what kind of data, what you take, and then what kind of learning? The second is, what kind of learning you are using for the system?
Yes, thank you for your question. The wireless sensor network, we try to collect the two kinds of information on land and in the air. For example, the temperature, the humidity, and some humidity in the land. To try about it because it's attached to about the growing of the artichokes. So we try to train in the data for the farmers
the decision about the waste, about some nutrition for the growth of the artichoke.
Yes, and then for the second question, what type of learning you are trying to use in this development of the system?
You mean about the machine learning?
Yes.
Yes. We use some technology of machine learning like deep learning, or also we try to the traditional machine learning for maybe clustering. For example, maybe at the end or something, we try to classification about the data. Yeah, like this.
Okay, maybe in detail we can discuss.
Yeah,
Thank you very much.
Thank you very much.
Thank you. One question. Okay.
I want to ask whether is it the monitor in the open area or in the closed environment? I mean, because if only for open environment, it's quite difficult to adjust the data. And also here it just monitor only or monitor and control. And also I quite wonder about the type of the data, like temp soil unit or some kind, because this thing is you cannot control. It just in my mind it's difficult to analyze the data in some kind of the environment like this. And also I want see the input like, okay, this is the weather sky like this, how is the yield or the quality of the artichoke, how can you measure, is that also wireless sensor or by manually check quality or yield of the artichoke of some kind? Yeah, this is all my question. Profession, totally sorry.
Yes, thank you for your question. Also, the discussion about the trust data from the big data we collect by wireless sensor networks. Yes, it's the problem in our project, and also this is only the proposal for this project. We will do next. We will do it from next year, and we also had some wireless sensor network. Collect the data. We also collect the from this year, and we also have some the data. And I think machine learning also better in deep learning, which we can train the data to adjust. We will adjust maybe about some knowledge about the trainings.
May I control? May I confirm this is the open environment? May I confirm that your experiment will be in the open environment?
Yeah, it means we will already collect the data past.
It's in open environment, right? It's not in the control or in the greenhouse or in the something.
Yeah. Yeah, in the city in Vietnam, maybe we can some system to control the interactions. You mean for weather. Or something we can control and adjust maybe temperature or maybe weather we can control. Yeah.
That means in greenhouse.
Yeah, it is our auto system. Yeah, we have.
Okay, we have one more question, Dr. Hidayat, in front there.
Hi, my question is, I want to know about the networking technology storage model and what's actually in the main control. Is it where you collect your data? Is all in the main control, and how's the networking technology works in this system model?
Yeah, it may use what to discuss about the technology to generate the data.
Yeah. In the control center.
Yes, also in the last question, it means we try to use some technologies in machine learning, like deep learning, to train the data.
Yeah, that's on the machine learning. So how about the networking technology, like how you collect your data or the storage model? Because you have are you automatically collecting the data or you manually collect the data?
Yes, I don't clear your question, but it means we have collect the data from wireless sensor network. So
Yeah.
we have the
Yeah,
data.
If you go back to your system model,
Yeah.
so you do have, is that some sort of like sensor for each view?
Yeah. About the sensor like this. Yeah. We also have the wireless sensor like this. We collect the data and we get the output data like number. Yeah.
Okay.
So we try to train in that data. Yeah.
Okay, thank you.
Okay, thank you. Thank you for good discussion. We have to conclude this session now. Thank you.